Okay, so hello everyone. My name is Oyinwenibi Fidel Kumo. And today I'm doing a demo video for an app which predicts tourist arrivals based off of some factors in sub-Saharan Africa yearly. So to begin, this is the app right here. It has an Ankara background to give it that real African feel. And I've already inputted most of the data, so let's just get right into it and predict. So as you can see, there's validation. So first of all, you can only predict between years 1999 and 2100. So there's validations that you need to put. So let's just put something like 2020, for example. And then also, it has to be the right data type. So obviously, percentage inflation is going to be numeric. So we're going to replace that. And as you can see here, it also gives you like a sample of what you should be putting so that you know the right type of data and a reasonable number to put should you put the data there. So it's going to put 5.0 and obviously change this. Let's make it 7.5 and let's predict. So as you can see here, it has successfully predicted. Let's move on to the tourism arrivals prediction API. Um, So we're just going to try it out for ourselves to see if we get the same number as we do in the application. So we're just going to try it out. I already have the values here, so we're just going to execute. As we can see, the values are very similar. It was just approximated in the app. Obviously, you can't have 0.69 people. So that is it. So moving on to the actual code itself, all I have to show you here is that this is where I call the URL that was hosted on render. So we did predict endpoint. And so moving on to the explanation of the data set. So this data set basically comes from a larger data set, which I filtered out. Um, it basically has indicators like economic indicators like GDP, inflation, unemployment, and also has indicators of tourism like arrivals, receipts, which means like how much tourists spend in a country per in a specific year, and some other columns, which is what this notebook is then based off of. So we have a notebook right here, and it explains the mission. I import all the libraries and just a short preview of the um, CSV file, the data set. Have some visualization. So we have distribution of the receipts, the arrivals, exports, and all the other columns. And obviously, or target our target column is arrivals, so tourist arrivals in 1 year per country. So we have all these scatter plots of other columns like tourist receipts, tourist exports, tourist expenditure against arrivals on this graph, on a scatter plot graph. And we have that for all the columns. We also have a correlation heat map just to better help us understand which columns are important and which aren't. Um, there were some values missing in tourism arrivals column. So we had to remove that, and then any other column that was missing with tourism arrivals present, I used the mean of the other columns that were actually present. So synthetic data right there. Trained standardized the model and trained it. Um, and then I tested the. So this is the for the linear regression. We can see that the RMSE here is 732,000, which seems huge, but we're dealing with millions. And the R square score is really good, 0.87. But I had to test the other models. But this is just a scatter plot graph. So this is what our predicted is going to be, and then this is what our actual values are. Seems pretty close, seems pretty accurate, which is why I got such a high R square score. Now, for the other models that I did, which are the decision tree and the random forest, I made it very simple. I put all three on a graph, so we have the RMSE here and the R square score here. Um, so as we can see here, the random forest is by far the best model because it has the lowest RMSE and the lowest R square score, and So I saved that, which was the random forest. So thank you so much for listening to my presentation. This is my ML summative, and I hope you like the app I made for you guys today.